Hello, hello. How's it going, everybody? Get a little bit of the radio voice today. I think all the wildfires and I guess that are happening in Canada right now are smoke's coming down here, and yay allergies. I had a little bit last week, but it's definitely affecting my voice today. So annoying for me, maybe more pleasurable for you, I guess. So strap in for some smooth jazz in the morning. Now that we got that out of the way, we are kind of doing a little bit of a new topic, but also a little bit of a callback to last week. Last week we were talking about a project called Cooklang, and that integration is in some way a parser. It feels a little bit like writing Markdown. You get a little bit of the syntax in there, but you can kind of write it in plain text. And then this gets, well, when you do that, that gets translated into a recipe, as in like the thing that you follow to cook something that you eat, not a programming term. And it's been a project that I've been kind of keeping my eye on for a while, and I've more recently kind of got myself involved in it. And because there was places that I saw that I could kind of jump into and help push. And part of that is specifically in they've rewritten a bunch of the parsers, or well, not the parsers, but they've rewritten a bunch of the foundation in with Rust, and have like a base parser now. And they've been the little ecosystem that they have going on. They've been taking that parser and doing things to get it into a place where it can be used in other contexts or other languages. And the one that is most interesting to me is the JavaScript, because we have it can be used on Obsidian, it could be used in VS Code, and potentially in a website. My cat is scratching the couch. And to do that, we need WASM. So what we were looking at last week was, if we take this Rust thing, what does it look like to then like generate something that is usable through WASM in all of those potential contexts and has TypeScript. So part of it was we got an idea of like how to wire it up and use it, and we played around with it a little bit. The piece that we kind of ended on was, how do we deal with the type generation? That is a bit of a rabbit hole, and that kind of brings us to our topic today. But first, before we touch on Specta and why that is useful, let's go over here to the display. We wanna look first at what I have a PR open for the work that we're doing on Cooklang. I want to take a look at it. Take a look at the Cooklang PR. And I think that's going to be interesting because it'll show us, it'll sort of like get the problem established. Like, why are we looking at this, and why is Specta part of the conversation today? And then also, how does it tie into Tauri? Because we're talking about Cooklang right now. So let's take a look at that PR, and then we're going to take a look at Specta in general. We'll say Specta-rs, I guess. And then from there, whoop, I misspelled Specta. No, that's not great. Apparently my delete is not working. That's frustrating. Okay, we are going to have to, because I don't have, those build software that you want to use and build software for yourself. Neat idea. I like the concept, but there's never enough time to make it perfect. So you're always dealing with like weird little inconsistencies. I don't have a way to close the app yet. So we're going to manually close it in our process list. I'm going to reopen it and hopefully our to-do list is not destroyed. Whoop. No, I clicked the other thing. Go away. Go away. No, 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 no. We're having a day today, apparently. Close. Go away. I don't want to deal with you right now in NVIDIA. Okay. Well, I spelled that wrong. I don't have a great way to fix it either. So we'll go with it. It is Specta with a T. So we'll take a look at Specta-rs, and then we're going to look at Specta. Look at tauri-specta rather. So that is a like implementation on top of Specta with wiring specifically to work within tauri. Hence the, I guess the thumbnail. I had to put it in the title here. We're going to look at like that integration specifically. And then we'll get into why. But first, let's look at this Cooklang PR. We got a bunch of stuff open. Close, 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 close. Okay. PR. So did a little work. Got a little hearts, I guess. This is what we did on stream. And I've since pushed a few other commits. What we ended up settling on, settling on is not quite the right word I was looking for, but what I ended up pushing as a commit in this PR is work using a crate called TSFI. There's a handful of crates out there with the specific intent to some working with serde to allow you to generate TypeScript based off of your Rust effectively. So I being the royal I, or we have written Rust in the Cooklang org to parse and like render this recipe effectively. That's written in Rust. We can use those functions and the downstream return of that in JavaScript. So we want to specifically have those return values be typed in TypeScript, because even if you're not using TypeScript and you're just doing this in a JavaScript environment, which is there's this playground right here. That's actually just vanilla.js. I guess we did make it a .ts, which is fine. But so actually we would, in this case, benefit from having it in TypeScript. But either way, even if you're writing this in JavaScript, TypeScript is built in a way, or rather your IDEs are usually built in a way where they can understand TypeScript and give you additional context, even if you're not using TypeScript. Excuse me. So having those types and the return type of those Rust functions in a described state is inherently useful. So coming back to the crate that we used, serde-wasm-bindgen. Was it Fran in the chat last week? Let's give a couple of call outs. Francisco was Fran in the chat last week. They ran across or found this crate. Where was it now? This one. And then I actually ran across it too later when I was reading through the digging into the Rust WASM docs more. They also mentioned this. So we saw this felt like potentially a good fit. And it gets us some of the way. What it did for us was, instead of having to try to return like a string, we could instead, this has been updated and has changed, but we could instead return like a JS value, I think it was. So we could use this Rust, this serde-wasm-bindgen to basically return a serde like type, or using serde to basically just say, return this thing, and you figure out how to make it into a JavaScript object. And that got us part of the way there. But the problem was it was missing the TypeScript part of it. So we got to the point where we could just say, take this complex value represented by a struct using serde and drive it into the thing that could be a JavaScript object. So we got the JavaScript part of it working. But TypeScript said that it was in an any. So we got a value back that was just any value, which wasn't great. So the second piece that we had to look at was the TypeScript part of it. There's a handful of crates, again, that I mentioned. The one that I ended up pulling in specifically in this commit and this PR was tsify. It is built to specifically work with serde-wasm-bindgen. So what this ends up giving us is with tsify and adding it to the derive macro. And this, I think this just needs to be in the top level from what I've seen. But this has to be everywhere, which we'll touch on in a second. But with that crate, we're able to return this type directly. And actually, I could probably I don't need to define it and then return it here. I could make that a little bit simpler. But in either way, we don't even have to use the serde-wasm-bindgen crate directly anymore to then convert the type into a thing that will generate a JavaScript object. By using those two crates together, we're able to just return this type directly, and it kind of figures it out for us, which is neat. So that gets us a part of the way there. But the problem that I'm going through with this crate is that we have to put the tsify derive at this top level. It will generate a type for this one specifically, which works. But I also need a type for this. It doesn't crawl and go down that tree of structs, as it were. I need to, in every case, do a derive tsify in every potential struct that I'm going to need in my TypeScript. If I don't put this on here, I don't get any warning or anything. My TypeScript file is just broken. So it generates basically a broken file, which isn't a great experience. But I understand why, because that functionally that is a much larger scope if you're going to automatically handle some of this stuff. So you can see that we look at sources from the main crate. I ended up having to put this in every place. And then I had to do a couple wasm-bindgen. Okay. That's what you get for programming at 1 a.m. And also that's why this PR is still in draft. I need to clean those little bits up. But I think what we have now is potentially something that we can I think I actually have that backwards. I'll deal with it. We need to fix it up anyways. So I think this will work for the moment in the Cooklang, just push the Cooklang TS forward. We can get it to work. We'll put some tests in to make sure we don't accidentally generate a busted TypeScript file. But it ends up meaning that we have to maintain this tsify in every one of these. So anything like downstream from that root crate ends up having to have a DSFI. And it kind of feels like it sort of infects the main crate. And you can actually see that we end up needing to have both TSFI and wasm-bindgen in the main crate. And they can't be feature flagged either, because I mean, I guess we probably could feature flag them, but then we have to like feature flag each one of these derives. It just becomes a lot. So like I think it's workable. I think we can potentially get this PR into a state where we can merge it and at least have a place to continue to iterate on. But I think potentially long term, we want to look at Specta title. So the let's look at Specta-rs specifically and what it's doing, and what it's doing that's different, I guess, than what TSFI is doing. So some of it is definitely I'm familiar with this crate because of its integration with Tauri and I guess let's just go Specta-rs. That I think I'll show. Yeah, there we go. Oscar is part of the working group too in Tauri. So there's and as well as Brendan. They've done a bunch of work with this, including the Tauri integration. And it works really nice. So they got this along with this. So it was sort of like a cascading thing. They needed it, so they built this, which ended up turning into this because they were doing Tauri stuff. And this is specifically on, I mean, the V1 is the recent release, but the docs that you're looking at are for V2, which is currently in RC phase, I guess. So specifically what we're looking at here is structs. You do the derive, much like in the other case. So conceptually, it's the same idea. And that, I think that's why the TSFI seems to work fine. But like, and if you look at this seems like it would work fine as well. But there's the abstractions here, I think, are potentially a little bit more interesting for like what's going on within the Cooklang setup. So in V2, there's Specta-serde is sort of this like base level piece. There's the integration that works with serde, similar to how this the serde wasm-bindgen works. Having a serde type or macro means that you can then use that type or structure. I don't know what the data piece is below it, but built on top of serde, you can basically like generate something from it. And there's like off of that, there ends up they're starting to do a bunch of work in a few different directions, some of which I think are potentially interesting again for Cooklang, because there's a specta-swift and a specta-Kotlin, both of which, if we look at Cooklang, we have bindings for. So they have a UniFFI, which is makes it available in these cases. So we could potentially be generating other thing like for other languages as well. I think those are a little bit more experimental. I don't know the state of those offhand, but like it's going in the direction that I think could be beneficial for what we're doing here. And then it also has some other interesting utils too. So like Specta, I'm personally rather invested in Zod because we use it in a bunch of projects, both client work and in like my own personal projects. And the most recent V4 seems really interesting. I'm really liking where they're going with stuff. But anyways, the fact that they're looking at an integration with Specta 2 is, or a Zod Specta integration seems really interesting too, because if you can not only generate types, but like generate a Zod schema off of Rust, that seems super interesting. Yeah, I'm very curious where that can go. All non-TS is experimental. Yes, yes, and like I did mention, we are still RC phase. So even like the main crate on V2 RC phase. Valbat at sometime at 2 at some point. Does the by the way, Oscar in the chat is this Oscar, if it wasn't obvious. Um, is the standard schema stuff that they're doing with I guess it's sort of between Zod and Valbot and what archetype? Is that standard schema stuff going to end up helping you out here too? Because like the intent of Specta Zod would be to generate like a Zod schema, right? Or a Zod file. I don't know what you would call it, but like basically you'd have a Zod function at the end of this, right? So, but I guess in that, you think standard schema is mostly validation, not definition. Yeah, it feels like it probably wouldn't help you out very much here, but it's not immediately obvious about like where your scope is for this. Not saying it needs to be, but again, everything is experimental here except for Typescript, which is part of what we want to look at now. So again, if you squint, this is sort of doing similar stuff to what TSFI is doing, but there's a few bits in here that I think will make it particularly interesting to use in the Cooklang use case, with some potential caveats, but we'll get to that. So there's this idea of like a type collection, and then it generates bindings. Hi. Oh, come on. Kitty wants to say, ow, 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 ow. Kitty's got nails. Ow. Kitty's got nails. Hi. Yes. Okay. Get adjusted. Sit down. All right. Okay. Say hi to Kitty. Okay. Anyways, as we were saying, type collection and this export to. These are the bits that end up taking your types and then generating the actual TypeScript. But what's specifically interesting about what Oscar has been working towards is hi, yes, what do you need? Come on up. I don't know what she wants. Just my attention, I guess. Oh my goodness. Come on up. I don't know if you can see her paw, but she's like pawing at me. And she needs her nails cut. Ow. It hurts. Yeah, so common use case, specta type, derive all of your types into a single file. I guess you really don't specifically say it here, do you? But we still have to do the type derive. Not the end of the world. I think that makes sense. Like there's already that expectation if you're using serde to kind of do this thing. But specta type is a little bit more generic, that it doesn't have like a dependency in wasm-bindgen. So we're not going to get like that leaky implementation basically coming in there. And the fact that having derived type could potentially be useful for cases other than wasm, I think is also set some precedence. Set it up once, you can use it in potentially multiple contexts here. But with this, you're basically saying like derive this type. what's interesting is that they do this. I was hoping to find the language, Oscar, because I wanted to use the same language that, like, use consistent language. But it sort of like crawls the types, or rather your structs, by decorating it. Well, I shouldn't say decorating. Putting in the derived macro. Decorating is more of a JavaScript thing, right? By putting the derived macro, it will also do all the structs that like build up into that. So we have a type 1. Type 1, I guess you need the derive on everything, right? But it does, from what I've been testing, it does throw errors if you don't put a derive. So if here we'll explain this, and then I'll come to that. We say we want to generate bindings for type 1. That is only one of the 3 types here. Type 1 is a struct which has a string, so just a like base level primitive, and then it points to 2 other structs. This one, or excuse me, an enum in a struct, which is these 2. By only specifying one, or like this top level one in your type collection, it will also include these as well. So not only is it like less leaky than I was seeing with other implementations, the you only end up needing to like specify one type, and it does everything below. Yeah, it calls the same trait method on all the type fields, so it recurses through the tree and collects up all the dependencies. Yeah, you should. That should go in the documentation. I think that's a huge feature. It feels like something that can kind of be an offhanded comment, but like that, I think that's kind of a big deal. You know what's also, hey, thanks for stopping by. You know what's cool at your work? You generate Python types from Typescript types. Yeah, it's especially since there's more and more, we're getting to the point where there's this like inner working between languages. FFI was sort of that like first thing, but then you ended up having to redo all this like typing and everything. And it's a lot of work. So the more that we can like do this code gen type stuff of these types, I think is really interesting. That's like the whole in the JavaScript ecosystem. I think RPC became like a big thing. I think because you had that same type, like, yeah, exactly, that type contract. I think that's the reason RPC became a popular pattern in the JavaScript ecosystem. I say popular as in like everybody's using it, but like in the media or folks talking about it, or things that you see mentioned all the time on social media, Blue Sky, whatever, RPC, I felt like kept coming up. And I think that's because you wrote the type once, or you wrote this like contract once, and you could use it in both the server and on the front end. Yeah, the same with protobuf, which might be what you're talking about. Yes, protobuf. I recognize it, but I am failing to recall exactly what. Like what I feel like I'm missing the context of it. There's like a specific protobuf thing you're talking about, right? Oh, building upon protobuf. Yeah, okay. So there's gRPC, which is also in that same idea, but then there's like a TS RPC? No, TRPC? TSRPC, yeah. A TypeScript RPC framework. So like specifically I was talking more about this, but like, yes, RPC in general is just a way to ensure communication between, a thing and another thing effectively. So like conceptually, the idea of having that contract, I think, is becoming more and more common, and for good reason. So this, I guess that kind of comes back to this actually. RSPC originally used TSRS, and that was another option that I had looked at. But it didn't have that dependency tracking, which I think is a big deal. So this was the one that Oscar was talking about. It's a framework for building type-safe web backends in Rust. Wow, I struggled with that for a minute there. This will be very familiar if you have used gRPC or GraphQL before. So sort of same idea. And that, like, this is in some ways Oscar's abstraction on it. Hey Rudrash, hey Chubb, good to see you. So like there's with specifically if you're building with Rust as your base piece, and that ends up being the like the contract or the generation point. What Oscar and folks are doing with this, I think, is really interesting to look at if you haven't already, because it has the base for some things that, again, experimental, but like depending on what you're doing, you might want to get involved. So shout out there, I guess. But that dependency tracking is huge. So I think this is potentially something that is going to be very beneficial to pull into Cooklang at some point. And that kind of comes to where that kind of comes to the caveat. So this idea works in a, it works. Not saying it doesn't work, but specifically in the case of Cooklang, we're trying to generate WASM. So we end up getting a bunch of like WASM file stuff with loaders and initializers, et cetera, and then TypeScript file. And that TypeScript file is based on that same like Rust generated stuff. If you're generating your types separately, you then end up having to like manually wire those two pieces up. So that's sort of like the base reason that I didn't immediately jump to pushing Specta forward. I tried it out. We were, Oscar and I were chatting about it a bunch, which is part of what actually dictated the stream topic for today. But it's just not in a great place to work with WASM yet. Mostly because you'd end up still having to do a little bit of manual work to like wire these like two separate TypeScript files up together. What do you need, kitty? Coming up. Do you need attention? Come say hi to the folks. Come on. There we go. She was indecisive. Hi. Yes. Was attention what you needed? Okay, we don't need tail on my face or cat butt on the stream. Where are you going? Get comfortable. Just sit. I'm trying to sit so you can sit. All right. So okay, we're not gonna. All right. I guess we don't need to type for right now. Can you see her? Yeah. Yeah, this crate is actually super neat. I love what Oscar's been doing with it. So you've used Specta as the type, the foundation for type exporting. Yeah, I think it's, at least to me, it's very clear that that's where you're going with this. And I love the idea. Specta and WASM framework would be super awesome. Yes, and that is a perfect segue. This. So there's whoop, no, wrong button here. Okay, now that I got a cat off my lap here. Wait, what's my hotkey here? This? No, this. I don't remember what my hotkey is to pull this up. Oh. Right control? I thought it was left control and space. It seems like my hotkeys not working here. Weird. Lovely. So anyways, before I got distracted, I think that's a perfect segue. I love what you're doing with Specta-rs, but specifically the next item on the list was tauri-specta. But this also sort of rolls into the WASM framework bit. So the interesting thing with that, I guess maybe we just search here. I don't know if it's gonna let us. Let's go here. Crates.io, TSFI. So what is specifically interesting about TSFI and why it not originally, but like kind of settled on it for the moment is it's got this WASM integration. So rather than you having to manually wire up a like generated TypeScript file and what wasm-bindgen is outputting, using these little bits here, you can return that type directly and it generates a thing for you with that TypeScript already wired up. Yeah, so like functionally Specta is kind of replacing TSRS. So no need to use TS. Yeah, so there's TSFI. I think TSFI is, it seems pretty much built to work with wasm-bindgen. So like the piece that's kind of missing with Specta at the moment, like it does this bits and the dependency tracking, which is amazing. But this is kind of our only option, and then we would have to manually wire it up. So what's sort of missing is like this little bit here, and that comes to a Specta and WASM framework would be super awesome. I completely agree. If we had that, we'd be able to do potentially some little thing like this that basically says, hey, when I'm doing wasm-bindgen and I'm returning a specific type that has that appropriate derive, use that in part of your TypeScript generation and the wasm-bindgen generation. So I think that's sort of like the missing piece if we would want to use it in the context of our work in Cooklang. We could use Specta, this future Specta, specta-wasm-bindgen, or whatever you would call it, specta-wasm-bindgen. Put a couple of type macros where appropriate, and then it should, in theory, just all work. I think that's kind of the missing piece. I guess we talked about that a little bit. Let's make that another topic. So if I can bindgen, if I can interest anybody in that work, I don't know that I would be up for or have the time to write all the code, but I'm here to get y'all interested in this and then helping Oscar out to make this framework even more amazing. So specta-wasm-bindgen, I think, is kind of that missing piece to like get this all working nicely with wasm-bindgen. So coming to our actual topic of the stream, I want to look at tauri-specta. And we were surmising that the level of documentation that Oscar has done for tauri-specta and that integration specifically is potentially going to look similar to what a specta-wasm-bindgen might end up looking like. So I want to look at tauri-specta, how that's sort of pieced together, and personally, at least, get a good feel of like how that code is written. And maybe I can get other folks interested in, and I could potentially help poking on a specta-wasm-bindgen from that. So rolling this all back to this original PR, we have TSFI in there. We might be able to just roll with that for now because we're probably not going to publish this immediately. So this might be enough to like get folks playing around with stuff. But depending on how quickly we can like spin up a specta-wasm-bindgen, it might be worth switching to that. So let's take a look at there's this like Specta foundation now, and in a separate repo there's the tauri-specta. Oh, you have a Discord. I didn't even know that. Nice. I'll have to join that later. I'm in so many Discords at this point, but like, if anything, it's kind of nice to just like have the announcements channel or anything. Okay, so we have two different versions. Tauri v1 is Specta r1. So Specta v2 does not support Tauri v1. I think honestly I've only used tauri-specta v2 with Tauri v2. I think so. So then we're on v1. This would be, okay, so tauri-specta v2. I must have just used the v2. I think I've only used v2 in a Tauri context. We've used it in a couple projects now. So tauri-specta v2 uses, you can see we've got some feature flags here. So you specifically have to like opt into the drive if you want it to work with that functionality. So in the case of like when we were trying to wire it up with Cooklang, that uses serde, we needed the derive to get it to work with and build off of serde. So it's using v2 of tauri-specta macros, which is in this repo. Oh, and then there's a workspace dependencies. Here we go. Okay, so v2 of specta is what this is on right now. And honestly, I think it's probably fine to do any of this work on v2. I don't see a reason to try to backport. Like if we would do a serde, or excuse me, a specta-wasm-bindgen crate, it probably is worthwhile just building on top of v2 right away. I guess we could look at an example real quick just to review how it ends up being set up. So if we look at Tauri, the Tauri integration here in this example, we have some commands. We do the macros. So Tauri macro, specta macro, it figures out and basically like generates types and a whole client to work with this with these functions. Derive, yeah, you can see we got some derive types here. Impls, functions, structs. Here's our main builder. So this is probably the important bit here. And if you squint, it's in the same vein of the base specta piece. So if we look at this like example in Specta-rs, we make this type collection, and then we from that output the type files. Kind of in the same vein, we do a bunch of these derive macros on top of all the structs, etc., etc. Then we we have to do this anyways. Like this is a piece that is required in Tauri when you're wiring up the Tauri commands. But this basically takes the place of, by passing it through this collect function using the tauri-specta collect commands, it sort of is like it like proxies to the Tauri command pieces. So like this ends up serving the same functionality that you would do if you were just doing Tauri commands directly. But then you also get a client for free, which is like, it worked really well in the Tauri ecosystem. If you haven't used it, and you use a lot of Rust commands, definitely recommend giving it a whirl, because you have to do all this work anyways. Plus, you just get a TypeScript client for free, which is a great experience. And then there's a bunch of like extra stuff here, so we can do debug assertion, it's like debuggy type stuff. Yep. And then here's the listeners. Nobody found a macro to plug the commands automatically. Oh, like do this automatically. I haven't seen anything. I mean, honestly, I kind of like the explicitness of it personally. In part, like this is fine because you have some commands that are all in this like single file. The file's not too huge, not a big deal. But if you start like pulling out commands into separate files, being able to like walk the tree, as it were, to find all those commands, I don't know. Maybe eventually, like as a DX thing, I think it potentially eventually makes sense. And maybe that's something that the tauri-specta integration can kind of help with, because it sort of has some of that functionality already built into it. It needs to do that for the types. So in theory, why can't it find all of the commands? Yeah, I haven't personally run in a situation where I have 100 plus commands, but I can understand that. I don't know. Does that make sense as like a feature of tauri-specta, Oscar? You're gonna stick with whatever Tori ends up doing? Yeah, I mean that makes sense. But like in theory, you're already doing the work to walk the tree, as it were. I don't know. If you're really annoyed, Chaub, maybe we bring it up. if you're interested in putting, because like some of it is like putting in the work to do the initial PR. Some of it is, even if you put in the work to do the initial PR, somebody still needs to maintain it. So it's almost like a tier list. If you're contributing to open source, there's a bunch of like check boxes or milestones that you need to hit to get a PR merged. There needs to be like overall ecosystem buy-in. So in the case of Tori, we have some like prior art doing it this way. I imagine that prior art is, oh, okay. I imagine that prior art is not a technical limitation, but just a time limitation. Somebody just hasn't gone through the work to make it automatic because it's additional time to write the code to do that. So like functionally, that could be something that the root Tori repo could do. And if folks have done it, excuse me, if folks have done it already, like you had mentioned with Tori GraphQL, it might make sense to push that forward as a thing. But that being said, even after ecosystem buy-in, there's also on like specific crates. So there's like two pieces of work. There's, I guess, in some ways, three pieces of work to get a PR merged and just generically in an open source repo. Someone needs to write the code and the docs and all the work that goes into the actual PR. Then it takes time and effort to review it. Honestly, reviewing it is probably one of the bigger blockers of OSS. If in general, if you are interested in getting involved in open source, having additional people just to review is huge. Like docs and review end up being the blockers a good amount of the time, because like in general, ecosystem buy-in and API architecture design are sort of like things that have already been decided, or there's prior work, or there's foundation to build off of, that by the time you're getting to a PR stage, the effort to actually like all of those like design decisions are in some ways mostly decided. So by the time you get to the point where you're writing code and you have something that you want to get merged, the blockers are going to be um, that review. And then the last piece of it is, even if you have like some ecosystem buy-in and you have the folks that have the time to be able to review a PR, once it gets merged in, it also needs to be maintained. And being strict or intentional about the APIs, not only the API of a crate or a package, but the scope of that API, because the more and more scope you take on, the more some folks call it bloated. I'm not thrilled by that term because it's sort of thrown around willy nilly, but it becomes unruly to maintain more and more integrations and features. So there's the projects that do really well are ones that end up being tightly scoped in their actual intent. Like, like we intend to do this thing. That then defines our scope, and this is our scope. If you need anything else, like in the case of Tauri, the plugin system ended up being very useful because we could define a tight scope. Anything outside of that scope ends up falling into the world of a plugin. So like there's potentially some prior art here that like in general it can be done. Like it's not inherently a technical thing. I think it's all the human bits that are potentially can get in the way. So coming back to what Oscar is saying, we can already discover all of your derived type calls through yeah. So like you can already discover most of them, or all of them rather. So like potentially it's something that Specta could do. You're hoping we can merge Specta into Tauri command and collect commands into Tauri's collection macro. Okay. So like push some of that upstream and actually have Tauri be dependent on Specta directly to handle that. I mean, I could see that being some reasonable. I could see that being reasonable. I feel like we've talked about that, haven't we? We've talked about that in either the working group or in prior conversations. But again, some of this, like the scope of this crate, is I mean, not only this, but also like this. It's already getting big. Like we're base level ecosystem stuff. So, yeah. Oh, Tauri is already dependent on Specta. Okay. I would say I remember conversations about it, but I didn't realize that some of that has moved forward. That's cool. I'm down. Personally, like the RSPCU approach of having routers. You define routers across files, and then you merge them. You end up having a file for each feature type thing. Yeah, I think too. Like coming back to this idea, the APIs have naturally been built with the DX of I'm making a demo app. And so like some of these pieces, I've made a lot of like on stream, we've made a lot of smaller apps. And the like integration points or what I'm doing based on the project, we kind of shift. Some of that is to show the options and show how you can do that. But some of that is just like it feels nicer to write it in one place or another. So I haven't personally run into too much of the like the pain of lots and lots of commands. But honestly, a little bit more API design or thought around that, I could see that being beneficial. And I mean, honestly, I think, especially where you're going with Specta in general, I feel like it would be a good fit for building Tauri on top of that. Because I mean, if you're unfamiliar with Tauri v2 now does Kotlin. Kotlin being the thing that, or one of the things that you can use to build Android apps. And also Swift, one of the things that you can use to build iOS apps. So like, it feels like, I mean, it makes sense why, and like I can see, but like, you're building the foundation for Tauri to also build on top of. There's sort of that like natural crossover between them. So like it looks really nice for what we could do in Cooklang, but also like tauri-specta seems to be a very interesting extension point for Tauri pieces to build on top of. Okay, so all of that being said, let us. I guess we can maybe call this one done. We're going to dig into tauri-specta integration. I got to remember to spell it right because I can't fix it because boop. Nope, not boop. Unboop. There we go. It will feel like doing a brain surgery. I mean, I imagine it's probably not as awful as it might feel like it is on the surface. I don't think that part of the code is terribly complex from what I remember looking at, but you know, big project. I only have so much time in a day to stay abreast of stuff. I need to probably more in my own free time look at what Specta pieces I've gotten into Tauri. I'm curious. I know I've definitely been down for the idea for some time, but all right. So we've got, let's see, we got a source, we have a macros, tests. I mean, this makes sense because we're doing, oh, this looks like a workspace. Yeah, workspace stuff. Like for the example apps, that makes sense. We don't, I mean, we just looked at the examples, so we don't need to look there. So we got macros and then a base source. Let's actually take a peek at the macros first. I'm curious what we got going on there. So we have nothing that jumps out at me as like things that I'm super familiar with here. Derive type. Oh, yeah, proc macro. Okay, that, yeah, okay. A bunch of this is just like helpers to write macros, basically. Like it feels like writing a macro in Rust is kind of a whole separate art from just doing Rust in general. But Tauri got the specta type impls for some Tauri built-ins. Due to some complicated reasons, we have to have them in Tauri. Oh, for specta directly. Okay. Yeah, I mean, honestly, it seems reasonable to me to start to build on top of what you're doing with some specta. Can you easily put the types on different folders in the front end? Like when it generates the client, are you asking if you can have like separate clients for these? That's a good question. I think I think the default is a single client, right, Oscar? It would be we've done some past streams. If you're curious into the actual like how it feels like working with Specta in Tauri, and like the output that it produces. Yeah, tauri-specta only produces one file, but you can put it anywhere. Oh, the actual like file that it generates. Yeah, you can put the file itself anywhere, but not like separate clients. I mean, I guess if you have hundreds of commands, I could see some. Yeah, working in different setups, matching your Rust modules with TS files. Yeah, I mean the scope that you started with makes sense to me. But I can definitely see some some potential use cases. Yeah, multiple. That's true. Multiple files with the multiple type collections. Is that going to be? Well, I guess let's look a little bit at the code here. We're doing a little bit with macros, and there's nothing too involved here. Let's look at though I guess the base lib. So we have the type collection, and the type collection is data type, type map, IPC. So the type collection is sort of like that container, and then it is the thing that you will generate the actual file. But if you have a command, so like in my mind, well, Specta in general is doing some types, right? Like Specta is more so about the type generation, and tauri-specta is functions that end up triggering IPC calls for the commands. So and correct me if I'm wrong, Oscar, as far as like the differentiation between these go, but Specta is going to give you the types. Tauri-specta additionally, along with the types, is going to generate a little client that calls the Tauri IPC basically like little wrapper functions, and then does the types for you, and then wires it up to the types. Tauri-specta is a bit wacky. It uses the specta function module, which collects function information and then allows us to build. Oh yeah, I forgot about that. There is. I don't know that we have anything on the root piece here. Let's open up docs.rs. Oh, that's not docs. This. Here we go. So there is, in the feature flags, there's a support for exporting the types of Rust functions. So when Oscar says specta function, that. So specta function doesn't contain an official export. It's just the primitives. Okay. So like the idea here is that with this feature flag and that stuff that Oscar's been talking about, that will like generate the function. And it sounds like some of that is just like wrapper pieces or the issue you run into with having an official function exporter is that we can't know what the TS function body should be. Yeah. So the specta function, as I understand it, is a hook or a way to like give you a way to plug into specta directly with a thing that describes what function should be generated. So the specta function is sort of just this like integration point. It's like I don't know. I can't think of a good metaphor. It's like the ISS, and you have all these space shuttles and stuff that can plug into it. That's not a great metaphor, but we'll go with it. And so in the context of tauri-specta, we know what specifically that function body should be, because honestly, the function body ends up being very, very specific, because what we're doing in Typescript or in the web view is just triggering that IPC layer. So we take the payload, pass it to this generic IPC function that Tauri has, which then does all the internal like fetch stuff to get it to the Rust backend. So there's as far as like the Typescript function body itself, there's very little that needs to actually happen in Typescript. So it ends up being probably not terribly involved to generate. So you can there's the derived type, as you mentioned, Oscar, and then the function piece is probably only used in tauri-specta, and then within tauri-specta, we can generate that like little IPC function. So let's see if we can run into that. And the other piece, as we're like looking through this, speaking of, we probably have about 40 minutes. We can still go. But as we're looking for this, I'm curious about the bits that end up generating that JavaScript function or the TypeScript function. And we can see if we can find the code that does that. And you don't have to tell me Oscar specifically. We'll look through all the files, but we'll look for that, and then potentially cases where what you have documented here and the setup here, how that might be applicable to what we're doing within WASM, or what we would want to do with something like specta-wasm-bindgen. Okay, so we have some language stuff, which makes sense. We're, in this case, still only TypeScript. So like, yeah. Oh, and JS doc. Okay, nice. If you're unfamiliar, TypeScript is a superset of JavaScript. So it's like a language built on top of a language. You can also, and when you're like bundling or generating, what ends up happening is that superset TypeScript gets compiled into JavaScript. And especially if you're like publishing it, you end up including a .d.ts. And that .d.ts is just a separate way to describe types that end up being used in JavaScript and like are able to map to those. A separate feature is, but one of the things that sort of naturally comes out of TypeScript is documentation. Like the types in some way serve as documentation, but you can also just write documentation directly into the TypeScript. And you can use a package called typedoc, which will generate like a documentation site or documentation report that includes all the examples in the docs you wrote in line, plus all the type information to generate that. The sort of like sibling to that is JS doc, which allows you to write docs inline in a JavaScript file, allow JavaScript to just ignore it when it's actually running, but your IDE can still like use those type hints when you're using these functions. So you can get some of the features that you might see from using TypeScript, but only be using a JavaScript file. Okay, anyways, so we've got some command register event. So here's a internal logic. Nice. Okay. So this is registering events, and this looks like this is called by collect commands to construct commands. So this ends up returning commands, which is a struct in this file as well. Okay, and this gives us the function. Yeah, bounds copied from Tauri builder invoke handler. So this invoke handler is like that IPC piece. And we've got function debug. More debugging, it looks like. Collect functions. So some of this you might end up recognizing from the public APIs. Export context, and then like this is what we end up getting. So like data type function is the thing that ends up being that like IPC function. Okay, now let's look at, we'll close this, open this panel back up, and let's look at, I guess let's look at Lang real quick. Yeah, there's not too much going on, I figured. And then out of curiosity, macros is also not too much going on. But this collect commands and collect events, those end up being those macros in the public API. So like this is the macro that you end up using when you define the commands. So that list of commands that you gave to that macro, which then gets handed off to Tori, that's this, which is doing that generate handler and then the specta function collect functions that we were just looking at too before. And a specific note, the structs in, I mean, anytime you do generics, it ends up being a rabbit hole, but like that's part of the scope that's been defined right now. Rust struct generics don't end up getting translated into TypeScript generics at the moment, as it doesn't support them. Is that a Specta support thing, or is that something else that's hindering that support? I think that it sounds like that's something that could potentially eventually be done. Tori doesn't support the generics. Oh yeah, in the actual like Tori IPC functions or whatever. Yeah, that makes sense. It sounds like classes and generics are probably one of those things that might make sense, but haven't been built into Specta in part because it's sort of like the first main feature is work with Tori, I think is sort of the MO. You basically only use them for the runtime on line 37. Okay. Generic command. Interesting. Is that my keyboard shape? Yes. So part of that is I get fun questions like this. Okay, so slight distraction here. I'm using a keyboard called what's that keyboard? Voyager. There we go. Wow. ZSH. No, not ZSH. Wait, is it? CSA. There we go. Wow. Okay, let's try this again. I'm using a keyboard put out by a company called ZSA, and the keyboard's called Voyager. It's a split keyboard. This is actually my key layout. So part of this is I feel like I'm like 85% of the way there in being efficient with typing on this keyboard. So that last 15% and some of those like weird macros or key combinations I still struggle with. So it's nice for me, but also you get to see a little bit of my struggle behind the scenes. So that's why I leave it up on stream. So yes, that's my keyboard shape. Can I show a bit? Boop. That's the right side. I went in the what is that, like I went all in, let's say. I have keycaps that are just blanks basically. So the like you can see a little bit of a color outline here, and that color outline is the actual like key color. So I have like no labeling on other than the color, which is mostly more just for like positioning. If I like move these allergies are killing me here. If I like shift or whatever, I need to make sure that my hands are in the appropriate places. Otherwise, all of my key presses are wrong. Anyways, okay. So Oscar said, yeah, it doesn't know the type of incoming data from the webview. Yeah. Yeah, so you have to like define the actual payload. So the benefit of having generics probably does not make sense. Okay, so then let's look at the builder. There's not too much code here. Render. Oh, and this is the actual rendering of. Okay, we'll come back to that. So it looks like there's not too many files that are like all of the code exists in that file, which is nice. I'm not a huge fan of the big massive files, but so we can see the IPC being imported. So we have the builder and the runtime. Nice. So here's our commands, and then like events. We saw those in the other file. This is the like top level impl. And so we do the specta thing, and this ends up, we basically end up getting like a list of commands that we can then generate TypeScript for. So there's not, I guess there's really not too much going on here, in part because invoke handler. What's the reason to have an invoke handler in Rust? Is this basically just like, is this kind of just proxying to the Rust side of things? I guess we'll have to look at what the, yeah, you basically proxy the tauri invoke handler. Okay. Can you show me the generated file, please, in an example? How much time do we got? What time is it? 11:20. Maybe we can take a peek. I might have a project where I have stuff generated already. I don't know if we have time to like go through a thing and generate it, like set up one from scratch, but I think I might have a generated file. We're gonna, the next thing we'll look at is the exported stuff, and you'll be able to see parts of what ends up getting generated specifically for tauri. Okay, so then in language, it looks like we get a little bit of globals, you know, listeners, sure. More listeners. So there's like the tauri event API. Go away. Open. There we go. I'm guessing like JS, TS, and RS or TS are just like different formats. But I'm guessing they're pretty much the same. I'm gonna start with TypeScript though. The main reason you do that is so that you only need to list all of your commands once. Okay, so that's like the proxying bit from your specta commands list to the actual like tauri commands list. Okay, so we have language extension and then a render, which ends up calling some of these pieces, and then the render commands. So we iter over that list of commands. JS, so some of the code might actually be here. This is the thing actually returning the function. So we're not going to see the code here. We'll come back to that. But the we end up getting a file and then we export the actual commands. Yeah, JSTS is a shared logic. Yeah, that's obvious now. Render events. So I'm guessing. We'll look at JS real quick. I'm guessing JS is very similar, just without a little bit of the TypeScript bits. Yeah, so like this here is JS doc, and this is, I believe, valid in any JavaScript context at this point. I think pretty much everything supports it. It's basically just a comment. So like conceptually, it's a comment that ends up being ignored by all, like anything trying to run JavaScript. But it's in a specific format that if your JavaScript parser or whatever is able to understand that format, then you'll start to get like type hints in, like in VS Code, you'd get type hints for any JS doc. Okay, yeah, so let's look at the JSTS. That looks like where most of the rendering has happened. So yep, this file is generated by tauri-specta. There's like a top level grouping that we have going on here. Render all parts. Yeah, so this coming back to what is the file going to look like? High level, this is what it's going to look like. A bunch of sections, and then we get the internal bits here. So commands is probably the thing that we specifically want to look at. return as result tuple. So some of this is like conversions from how Rust handles errors to how JavaScript, how you'd handle that error in JavaScript. And here's the tauri invoke. So this effectively what we're doing is we need to await, because anything reaching out to the Rust side of things is going through like effectively a fetch. So we need to await that fetch. So tauri invoke is the upstream tauri function that actually fires off that all that like fetch or whatever. There's a couple different ways it does the communication depending on your settings, but either way, it fires off that like that payload or request, I guess, to the Rust side of things. Here's another one, handle result, where like converting a Rust result into the JavaScript equivalent. Events map and events data. Where is this? Where is tauri invoke used? Yeah, here, function. So this is the piece that when we iterate over and we return that value, that's this. So we separate the args by a comma. We do the promise thing, and then format. And body is a string. I'm guessing body would be the tauri invoke. Okay, so like functionally, what we end up doing here is there's kind of like two main pieces of work. There's the two-ish on top of what Specta is doing. So Specta is doing that work to get all the TypeScript stuff going. With that TypeScript, then tauri-specta builds on top of that to do sort of these two pieces. There's those macros to collect the commands and the events. That collection ends up doing basically like two high-level pieces, passes it off to generate actual TypeScript files or JavaScript files to then be imported in your code. But then also like passes that information off to tauri to be the thing that actually allows tauri to execute and handle those functions. Okay, so there's, I think we got a good idea of the function itself. Let us look. Let's see real quick if I have anything that we could use as an example to. Let's see. I guess we might have something in the playground. Tauri playground. We're on Verso runtime. We are going to play the game of, did I forget to commit something? No, it looks like I didn't. Okay, that's good. We're gonna switch over to the main branch. I'm pretty sure I pushed all this stuff. Okay. Let's double check. Advanced async commands. I think I used it here. I'm pretty certain that I used it here. I guess it just shows up in the create, right? Specta. tauri-specta. I did. Go me. And memory mostly. I'm not. Okay, so it's generating. Oh, actually, I did actually commit it. In part because I could just click over to it and I use it as an example. So, because Chaub, if you need to go talk to people to sell them on the benefits of using this, let me give you a link. Tauri playground. This is what is generated. Boom. So we get, this is a couple versions behind, but not too far. So I think this will be pretty close. But you can see high level again. We've got these sections. I'm not doing anything with events, or I don't really have constants, so we don't have to worry about that. I don't really remember what I did with the user-defined types here, but and then we have the like tauri globals. So there's the like wiring up to the tauri API core and event and the webview window. So like these are the bits that are needed to like fire off those invokes and such. So then we've got this proxy object which does the work to work with these event listeners and such. But my actual commands are these two pieces. So like I was saying, there's the reason that this ends up being an integration that isn't terribly involved. Maybe there's a better way to say that. There's a lot of work that went into Specta. I don't want to belittle that, but like as a function that you need to generate, in the case of tauri-specta, there's not too much that's required as far as user input goes, because the function body is sort of defined already by tauri. All we're doing is executing, or like we're giving a payload and using this tauri invoke directly. So like all of the user generated handling ends up being in Rust. So the user writes Rust, passes that command to the macro and the builder, etc., and you get this. So like there's very little that is needed to actually generate. Like the user can do whatever they want, and there's very little that's actually needed to generate the TypeScript part of it based off of that user input. So it's an integration that ends up working really nicely because it kind of just feels like magic, where you get this, you write Rust and you write your Rust commands, and then you just get a client with it. So it feels very much like the magic of these like RPC clients, where you write your contract once and it just sort of wires everything else up for you, and then you just use it like any other client you might use from like third-party libraries or something. But you get the payload, the type checking. This is all typed. This is specifically a tauri channel, so we're doing some a little bit fancier stuff with the tauri channels, and it handles the promise, and then it's just firing off an invoke. So you, like the bits that end up being really useful is like this is all typed, and you can just use this, and this is all effectively defined by your Rust, which is a really neat integration. So hopefully that answers your question thoroughly. The last bit that I want to get to, we got maybe about 10 or 15 minutes here. How, I guess we can cross this one off. So how does tauri-specta, I don't know, I always forget that T, map to, we're going to say specta-wasm-bindgen. I think that's the last piece. And then we will call it a day. So let's close this, I guess. Yes, you're welcome. I appreciate the questions. That was a great question. So how does this map? What if we, because that TSFI is doing this like macro thing already. So if we would take a quick peek there, I imagine we ended up having to do something similar. And there's not too much going on in here. So if I can potentially pique folks' interest, there's a little bit more in here, but like this work here, this is all figuring out the TypeScript stuff. Specta's already doing all of this stuff in the macro, I think. The thing that we would need to look at potentially, I think kind of the only little thing would be to, well, we need to wire it up with tauri-specta. So that would like, I still think that makes sense as a requirement, because we end up needing to do these like JS cast and JS value. Yep. So we need a feature wasm-bindgen, and like this makes sense for how they set up this crate, but it also means that wasm-bindgen ends up being kind of leaky. So I need to put this tsify everywhere, but then also like I need wasm-bindgen, I guess. So we got into JS, from JS, in function into JS, function into JS. Oh, so there's feature JSON. They're mutually exclusive, but not feature JS. Okay, so all this is doing is a JS value from serde map to this. And I'm not sure what JS versus JSON. I guess JSON would just be like a generic object thing. JS into serde. Wait, feature JSON. Oh, from JSON. Okay, so here, yeah. So JS value from serde map into this thing. We got to do a little bit more if you're doing more of a JavaScript object, but like there's not too much that's going on here, I don't think. And this ends up giving us this tsify. So like I think that's kind of all that we would. It's probably what, like 2 pieces ish. There's the little bit of wiring to get it to just work with serde wasm-bindgen. So you need a little bit of wiring there, and then that wired into like doing the type collection stuff. So I think like functionally what ends up happening is we would write a thing that does the type collection for you effectively. So it'll handle like the type collection and then wire it up. One thing Specta wouldn't allow is functions with impl blocks, but you'd be open to supporting that. Yeah, and so that was part of what we were, for context for other folks, we were discussing, Oscar and I, in Cooklang, if we wanted to use it, impls are currently kind of in the way. Maybe that's not a good way to say it. It's implemented with an impl currently. We would need to like shift stuff around, but like none of that's inherently set. It was set up that way, and it was convenient to do it that way. So I think we have some ability to avoid an impl at the moment, which would allow us to push things forward a little bit sooner, potentially. But it sounds like impl blocks might be something that I don't know if we would need it in Cooklang or not. But if that's something that somebody else needs, yes, what Oscar said. Hey Nicola, good to see you. Glad you could stop by. It wouldn't be a blocker though. You can just have top level functions like tauri. Yeah, I think that's potentially fine with Cooklang. I guess if we go over to the base TS parser branch I've got, we can open that up real quick. We have an impl parser, but I don't think there's anything that's inherently requiring that. Like there's this function render, and then from that, so like the use in the playground is sort of a like base level example, or at least that's what we've been using it as. So the wasm-bindgen stuff, we have to do the init. I wonder if we could potentially remove this, and we might do like a little bit of JavaScript directly in the package. Like we could potentially do in JavaScript a class that then just pulls in some of these functions and sets up a nice class for you, and then does this init like in constructor or something. I think potentially that might make sense. But the way they're using it, and the way I think they set it up as an impl is because they do this new parser. And part of that is that there's the idea of extensions. Yeah, actually you can see it here. So when you generate or do a new parser, that comes with a set of default, like the, what's the word I'm looking for? It defines a set of default extensions, but you can either like set those extensions and the like units when you first call the constructor, or you could do it after the fact. But in general, you kind of pick one, and every operation after that is going to use that same like parser. I suspect it isn't going to be common for folks to want to have like multiple potential units, or have some like weird thing where like every recipe can potentially have a different set of units. I can maybe see like somebody doing like a language folder or something like that, where you have or you might regenerate and reparse multiple times. But it would be like, I want to parse all of like this group of files with, like North American imperial units or something like that, with these specific intentions. And so like once you've defined that parser, then you're just using it directly. So like there's nothing inherently required in having an impl, I don't think. Because like in reality, all we really need to do is parse. But doing the units and stuff, we could potentially just do that like in a JavaScript class. I don't know that requires an impl in Rust to do that work. Because we can potentially just like write our own little constructor that does this little bit of wiring here. I don't think that would be too big of a deal. So I don't. It would potentially be nice, but I don't think that's going to be a hard blocker in this specific use case. So I think the bit that we would need to worry about is how do we, like, I don't know that we need to do all the drive stuff, because all of this, I mean, we would maybe have to like look at some of these macros and what they're doing, like wasm-bindgen. Yeah, so this might be the only one that we might need to potentially look at, because I think we need the wasm describe and wasm describe vector to at least define that like top level thing. So there's a little bit of a lift potentially. But I don't think it would be too bad, because I think Is Specta is doing a good chunk of that lift already. So we would potentially need some of this, like the wasm ABI stuff, and then we need that wiring and the type collection stuff. So I think that would be the other bit, is I guess we've got a one interesting observation is that wasm-bindgen and wasm-pack doesn't seem to generate types. No, and that's I appreciate what they've done with wasm-pack, and I understand that it seems like the team isn't too big and they haven't had time to work on it, but it feels like I wish, like in general, I wish the ecosystem would have the bandwidth to like push that forward. It seems like folks are potentially interested in that, but the folks that are directly involved with it right now don't seem to have the bandwidth to push it forward. Like there's not even a watch command. When in Cooklang, in the setup we have with Cooklang, I had to like wire up my own watch command to just rerun wasm-pack over and over. Which is, I mean, we have the Rust incremental stuff. It would be so great to just have an incremental watch built into it. Oh, you said does seem to generate types. Yes, it does generate some types, but they're very primitive. So like we can turn on TypeScript generation, but if you like, and you can return like a string, and then that'll work. Like you'll get the TypeScript type that says it's a string. So like we've got a, did I open up the right branch? Bindings tree. Oh, this is on the main. This is what I want. Base TS parser. In the librs, we have a struct called fallible result that returns two strings. Wasm-bindgen actually did just fine with this. We got the types for that, but like it's so simple to be almost not useful. Sure, a string is nice, but also like the API at this point is so simple that having the types available is not like I could write the type in TypeScript and just be done with it. So it does do some types, and you do get a TypeScript file, but not enough for the bulk of use cases, I would feel like. And that's, I mean, I don't think that's inherently wrong by design. But the like that is in part, I think, where is it? Serde-wasm-bindgen comes into play. Like this is a crate makes sense to me. Take serde and the more complex types that can come from that, and then generate the TypeScript off of that. And that works pretty good. Or well, not the types. Excuse me. It takes a more complex value and then just maps into the appropriate stuff to be returned. So like this handles the JavaScript return part of it, but it still doesn't handle the TypeScript part of it. So like if you get anything more complex than a string or a number, it just says it's an any. It makes it an any. So what we were trying to do with returning a like type recipe, it was just an any. I'm going to come back to your question RFS in a minute because it's sort of off topic. Just so you know that I didn't miss it. So I think there's probably that little bit left that we need to look at, and we've got like 2 minutes to look. But we need to do the collect part of it. So I think there's some level of like, we in this case are doing the collect commands. This ends up effectively passing off then to like collect functions. I don't think we need to do collect functions necessarily, because serde wasm-bindgen I think is going to do the function part for us, or at least the wiring up to then get it. Or wasm-bindgen plus serde wasm-bindgen is going to get us the functions. So we just need the TypeScript part of it. So I don't think we need to do the specta function. I think we can do the implementation that ends up basically passing off to, because we just need that. We need the TypeScript. So builder. So I guess in reality, we just need like kind of this builder. So I think we need that like wasm macro thing. We need this macro thing with the into wasm ABI stuff to then pass off to expand into wasm ABI, self into JS. Yeah, so here's that into JS that we were looking at before. So like I think we need like what they're doing here to then pass off to like the tauri type collection thing effectively. Because this like into ABI and from JS into, like, all of these are calling that they're calling this into JS, from JS. So like it's calling these, and these are basically saying, well, this is the piece that generates the function through the serde-wasm-bindgen. So serde-wasm-bindgen is doing the work to generate the function. We just need the types, I think, from Specta. And I think that makes sense because you're generating wasm, so it doesn't really make sense to try to get into that and also try to deal with the actual functions from there. But if we can get the types wired in through that sort of same, this builder ends up doing a type collection effectively, right? Named type. Yeah. Events, commands type. And then the commands comes from the, is it the lib? No. Builder, lang. Self types is a type collection. Okay, yeah. That's what I was trying to double check real quick. Yeah. So I think I see where you're going with this tauri-specta. Makes sense as a potential good example. So if we sort of like meld some of the pieces together from what they're doing in TSFI and their integration with serde-wasm-bindgen to what we're doing here, I think we can cook up a crate to do this, which would be really neat. Okay, I think that's where we're going to call it for at least this topic. I wanted to touch real quick RFS. Do you think, how hard is it to write Shadcn CI components to Dioxus components? I'm not terribly familiar with what they're doing in Dioxus. I am saying that right? I don't know that I've said it out loud. Dioxus components versus Shadcn CN. Dioxus. So it is built on tops of some of the tauri bits. But like you're writing Rust. I haven't looked at it closely enough because I haven't had this specific use case. I don't think they're using tauri, the top level crate, but I think they're using Rye and Tau maybe. Don't quote me on that, but I think that's what it is. And what they're doing is they're doing that so they have more control over. We write Rust and make I believe it's WASM, and then they handle all the work of like getting that WASM file into a context that is actually usable. But honestly, I'm not the person to ask is probably the simple answer. I thought there was a way creating UI. I thought there was a way to, so it's just HTML. And like effectively, like that's what those components are too. So the thing that I would look for would be some sort of like mapping. You write a thing in Dioxus and it converts it into the equivalent like HTML. But instead of HTML, you could potentially use something else. I think Shadcn CN does. I think it supports bare HTML plus CSS. I don't recall offhand. I think I've only looked at it in the context of using it with React. But like this effectively takes the place of React. Like you wouldn't use React with this, I don't believe, because it does all the state stuff too. So that's what I would look at is Shadcn CN's like CSS. Is it Shadcn CN? Honestly, I haven't. These are two packages that I haven't actually said out loud. But anyways, All right, I think that's where we're gonna call it today. Whoop, not that button. There we go, that button. It was fun chatting. I think that's what we're gonna call it today. We are going to Shadcn Cloudflare. Yeah, right. The everything needs to be hooked up to a service these days, right? Yeah, it's very similar to Tori, in part because it's built on top of Tori pieces. Some of the lower level tech that Tori has pushed forward, that's also built on. As if I recall off the top of my head, they might have since changed or whatnot. So I'm definitely not an expert with it, so don't quote me on any of that. But I think they're doing WASM to then and basically write your UI in Rust, and that gets generated into WASM. I believe so. The Dioxus hot reloading Rust stuff that they're working is so insane. Oh, interesting. Interesting. And there's like a company buying this too, right? I think. Maybe I'm wrong. Dioxus Labs. I think so. I think with the intent to be able to like deploy the thing too. Yeah, they're YC backed. Yeah, that helps. Money buys folks time, and time is what a lot of these things need. So speaking of time, if you're at all interested in pushing anything that we've looked at today forward, I think Oscar has a Discord. Check out the Specta repo, and there's a link there. There's a few pieces that I think Oscar is open to PRs and pushing forward. So if you're interested in those as well, or if I can get you interested in some of this wasm-bindgen stuff, because I would love to see some of it push forward, let me know or let Oscar know, and we'll see what we can do to enable that. And if you're interested in, say, getting involved in Tori or whatnot, again, PR reviews and docs. These are, and in any of these other places too. It's going to be a lovely way to get involved, because those are inherently, you need people to do that right now. And there's a lot of like cognitive overload to do that type of stuff, and it's inherently different than just writing code too. It's a whole nother skill set. So get involved. Would love to see folks get involved. And if your company is using any of this stuff too, pay for folks' times. There's a handful of ways that can be achieved. If you're interested in throwing money at the problem, reach out. There's plenty of folks that are interested in pushing it forward, but you also have to have your bills paid. So happy to make connections. I'm not sure what we're going to work on next week. I think this might be kind of the end of where we're going to be going with stuff in this like little line of work. We might do a little project thing next week, but we'll see. I'm not terribly keen on anything specifically at the moment, because I have many loose ends I need to tie up on different projects, and Cooklang being one of them. So I have some things to do there, and some things in other projects. We might just pull in a project next week, but hit the follow button, subscribe, whatever. I'll see you next week, Tuesday. If you want to chat about anything that we've talked about on stream today, feel free to hop in the Discord as well. I need a short link for that. Speaking of to-do lists, we're gonna get on that. I am going to drop a link now before I forget. That's the little Discord community that we have going. If you want to chit chat about any of if Discord's your thing and you want to chit chat about stuff we've talked about on stream further, we'd love to see you. So get involved. start experimenting. I'll see you next week, everybody. Have a great rest of your week, everybody. Bye.